Right, so this comes under radians. It is the radians section in the book. They won't necessarily state that in the exam. You just need to remember that you are working in radians, okay? You can always check the angle. Just remember, because this is in radians, that you are using radians on your calculator. Two formulas that we need to remember is that arc length, or L, is just r theta. And that the area is a half r squared theta. Okay, don't try mixing the two between degrees and radians unless you're very careful with how you've sorted out your formula. So we've got the diagram that's got a sector of a circle. It's got all these different pieces of information, and then the shaded segment is bounded by the line DC and the arc from D to C. Show that the length of AC, so this length here, is 7.90 centimeters to three significant figures. So I'm just going to use this triangle that we've got on the right hand side here, and if I've got two sides in an angle and I want the third side and it does not have a right angle in it, we're going to be using cosine rule. So remember, cosine rule is a squared equals b squared plus c squared minus 2bc cos a. So most important thing is with the cosine rule, the angle is labelled as a, so I'm actually going to relabel my angle as A, so I'm going to make this one B. Just remember that you've done that for any future parts of the question. That means that this side would be A, this side would be B, and this side would be C. So we get the side we're looking for is equal to 8 squared add 11 squared minus 2 lots of 8 lots of 11 cos and 0.8. And again, just make sure that you are in radians. So we get 8 squared 11 squared, 2 lots of 8 lots of 11, and then cos of 0.8. And you get that a squared is equal to 62.3796, and so on. If we square root that answer, we get that a equals 7.89807, which means it is 7.90 to three significant figures. And remember, for a show that question, you do want to show every single line. Okay, find the area of the shaded segment. So the segment is just this part here, which means what we're going to do is if I find the area of the sector, and then I can take away the area of the triangle. Now, if this is a sector of a circle, as it says in the description somewhere, ABC is a triangle and a sector ACD, sorry. So if this is a sector of a circle, then this line and this line are the same length, so we're going to need that information later. So area of a sector, first of all, is just a half r squared theta. So in our case, that's a half times 1.7, times, wrong way around, 7.90 squared times, and then theta, which is 1.7. So I've got half times, I'm going to use the answer button since it was the last thing I typed on my calculator, times 1.7. We get the area is 53.022676, and so on. So I've got the area of the sector, I just need the area of the triangle. So remember, for the triangle, what you've ended up with is 1.7 as the radians, and I've got that length there is 7.90, so that length there's also 7.90. So area of a triangle, we know, is a half AB sine C. So A and B are the two sides, C is obviously the angle, so you've got a half times 7.9 times 7.9 times sine of 1.7. Okay, that works out as 30.9449. And then remember, if we want the shaded segment, all we're going to do is you're going to do the area of the whole sector and you're going to take away the area of the triangle. So we're doing 53.0226 minus 30.9449. You get an area of 22.1 and it would be centimetres squared to 3 significant figures. Okay, last part is find the perimeter of the shaded segment. So for that, I'm going to need to work out that side length there and the arc length. So arc length is the nice and easy one. That's just r theta, which in our case is 7.90 times 1.7. You get 13.43. The other one, again, is a triangle where we know two sides in the angle. We want the third side, so I'm going to use cosine rule again to get me that length there. In which case, if I redraw the triangle, what we've got is, obviously again, labelling your angle as A. These sides are B and C. So I get A squared equals 7.9 squared, 7.9 squared minus 2 times B times C times cos of the angle. Okay, that works out as 140.90, so on. We're going to square root that to give us that the side length we're looking for is 11.87. And then if I want the perimeter of the shaded region, I just need to add together that length there that we've just worked out plus the curved arc that we already worked out. So I get the perimeter is 11.87 and 13.43. You get 25.3, and it's centimetres because it is perimeter this time. And that's it. No, I've got one more radians question. So if we look at the next one, we've got much simpler diagram this time. We've got express first of all 46 degrees in radians to 3 significant figures. So all you need to remember every time is that pi radians is equal to 180 degrees. So to get to 1 degree, we divide by 180. So I've got pi over 180. And then to get from there to 46 degrees, we're going to multiply by 46. So I end up with 46 pi over 180. They do want the answer to 3 significant figures. So we're just going to type that into a calculator. You end up with 0.803 radians to 3 significant figures. Right, find the length of the arc AB. So we now know that if that's 46 degrees, that because we're working with sectors of a circle, we need to be working in radians, in which case that is 0.803. And then we've got those lengths as 8 centimetres. So for arc length, we're just going to do L equals R theta. Remember, L just is the letter we use for arc length. So I'm just going to do 0.803 times R, which is 8. And you get an answer to 3 significant figures of 6.42 centimetres. And then find the area of the sector. So area is a half R squared theta. So you're going to do a half times 8 squared times 0.803. We get an area of 25.7 centimetres squared, again to 3 significant figures. And that's it. That is radians.